Ladies and gentlemen, it's my great pleasure welcoming you at the University of Zurich in a complete digital format. On behalf of Universitas 21, I would like to welcome everyone to this fascinating keynote talk and expert discussion. Today, we have invited the world-renowned climate expert Thomas Stocker. Thomas is professor of climate science and he's the head of the Department of Climate and Environmental Physics at the University of Bern. He has led pioneering work in the climate science to prove scientifically that ongoing global warming is real. From 2008 to 2015, Thomas was co-chair of Working Group 1 of the Intergovernmental Panel on Climate Change, IPCC. The resulting report, which was adopted by all countries under his chairmanship in September 2013, formed the scientific basis for the Paris Climate Agreement. It's now my pleasure to welcome Thomas Stocker.
Ladies and gentlemen, welcome. Climate change. Have science and education failed? I'm going to talk about this in the next 30 minutes. If we look at the leadership and the age distribution across the countries today, what we see is relatively dark colors. These dark colors indicate a relatively high age of the leaders in the 195 countries of the world. In fact, the number of state leaders has a maximum at 60 years of age, and about half of the leaders in 1978 were at the age of 21 or younger. What does that mean? That means in 1978, many of these leaders have started their higher education, be it at university or higher schools. 1978. This was also the year when the carbon dioxide concentration in the atmosphere was not as high as today. In fact, if you look at the graph, you see a slight increase of carbon dioxide concentration. Something to worry? Well, scientists in 1978 did worry. My colleagues from the University of Bern have published in the magazine Science in 1978 a paper entitled Predicting Future Atmospheric Carbon Dioxide Levels. An inconspicuous title, but in this paper they made an interesting statement, a statement that reads, a maximum permissible CO2 level might be found which should not be exceeded if the atmospheric radiation balance is not to be disturbed in a dangerous way. Already in 1978, scientists were aware of the potential danger of large and high concentrations of the greenhouse gas carbon dioxide. They even went further in their paper and made a prediction about the carbon dioxide concentration in the year 2000. Look at this prediction. That was their prediction in 2000, far away in the future, and today we know that the scientists were right. They understood the system, they were able to make predictions, but has it changed anything? Well, along with the carbon dioxide concentrations, there are also measurements, millions of measurements of surface temperature around the globe. These temperature measurements tell us an unequivocal story of warming. In fact, the planet has warmed by about 1 degree since 1900, as you can see on this graph very clearly. The leaders in 1978 that barely entered university were at that level in the temperature curve. Had they listened to the science, they probably would have known what is in store for the planet. Therefore, have science and education failed? Well, let's first look at science. Let me make 3 points. Science, since 1978, has delivered the facts. Science has assessed the future risks. And third, science has communicated to the policymakers. I will give you 3 examples of these points. Here you see Dome Concordia, a research station in Antarctica. The sea is about 1,000 kilometers away from this remote station that is located at 3,230 meters above sea level. In 1995, scientists have started to drill down into the ice, more than 3 kilometers, to access very old ice. This old ice contains information about the past. And if you look at an ice core, more than 50 different parameters have been analyzed on this ice to give us a very precise history of environment and environmental changes, and more importantly, to provide us with a context of climate change today. If you take a closer look to this ice core, you discover that the ice core contains bubbles, air that is trapped in the ice, air that is old and contains greenhouse gases. If one manages to measure the concentration of these greenhouse gases, carbon dioxide, methane, nitrous oxide, and a number of other gases, we're in the position to record the past history of greenhouse gases. This is the work of many scientists since 1978, and I'm proud to say that the University of Bern has provided this unique record of 800,000 years of carbon dioxide history. What you can recognize on this time series is the up and down, the natural variations of carbon dioxide over the cycle of the ice ages. 8 complete ice ages have been noticed in these ice cores, but on the far right of this curve, you discover where we are today. This is the context in which we discuss climate change today. This is the context in which we discuss carbon dioxide concentrations in the atmosphere. They are 30% higher than ever in the past 800,000 years. You can also look at the similar graph for methane, the second most important greenhouse gas after water vapor. There the increase is even more dramatic, 150% higher than ever during the past 800,000 years. That steep increase that you see at the far right of this curve is due to human activity, due to the burning of fossil fuels, coal, oil, gas, and the deforestation in the tropics and the mid-latitudes of our planet. The scientists have also looked at the risks that are entailed in the increase of carbon dioxide and other greenhouse gases in the atmosphere. They have come to the conclusion that climate change is a threat to sustainability. Let's look at the facts here. You see on this graph simulations of the 25 most renowned centers around the world. Every big country has a center where high-performance computers are running climate models to estimate the temperature evolution in the 21st century. The scientists have investigated 2 scenarios. A red scenario, you could call it business as usual, and a blue scenario, which is a climate protection or climate mitigation scenario. These models provide us with a detailed information about temperature changes relative to 1900, the beginning of the 20th century. In the business as usual scenario, we see a hot world at the end of the 21st century with a global mean temperature that is by 5 degrees higher than at the beginning of the 20th century. The climate mitigation scenario, given as a time series in blue on this graph, shows a different world. There is also warming, as there is warming that we are already living in today. But the warming is not nearly as dramatic as you see in the top panel. The warming is moderate. It stays below 2 degrees Celsius. And therefore, these climate models tell us there are many futures, and the futures depend on us, on our decisions today, and on the decisions of future leaders in the 21st century. The third point concerns whether science has actually left the ivory tower. Science in climate change has communicated to the policymakers, and it has done so already since 1990, when the first assessment report of the Intergovernmental Panel on Climate Change has appeared, right in time to prepare the policymakers for the Earth Summit that took place in 1992 in Rio de Janeiro, and which was the birthplace for the UNFCCC Climate Change Convention. In the subsequent years, 1995, 2001, 2007, and 2013, further reports have been published. This reflects the fact that climate science is not static. It develops. The scientists look further and further, more deeply, more details into understanding the Earth system and its vulnerability to the increase of carbon dioxide and other greenhouse gases in the atmosphere. In the last report that appeared in 2013, the communication was extremely clear. Warming of the climate system is unequivocal. Human influence on the climate system is clear. Continued emissions of greenhouse gases will cause further warming and changes in all components of the climate system. And finally, limiting climate change will require substantial and sustained reductions in greenhouse gas emissions. You may think these are sentences of a journalist or a science writer. They're not. These are sentences that were approved in consensus by 195 countries on the basis of the scientific foundation that is found in the 1,435 pages of the report Climate Change 2013. This has led to a remarkable convention and agreement, the Paris Agreement, that states that holding the increase in the global average temperature to well below 2 degrees Celsius above pre-industrial is the goal of that agreement, and efforts should be pursued to undertake rapid reductions of greenhouse gas emissions so as to balance emissions by sources and removal by sinks. This sounds a bit complicated. In essence, it says carbon dioxide emissions must fall to zero within the next 30 years. This is the Paris Agreement, which would not have been constructed and agreed were it not for the scientific basis that the science has communicated to the policymakers. But that's not enough. As we can see from the emissions, the most up-to-date time series of global carbon emissions in billion tons of carbon dioxide. Since 1990, you see a curve that only points upwards, with slight little bumps during the financial crisis, but an extremely resilient system that goes back to high emissions right the next year. You see that in 2019, we have emitted the maximum number, the maximum mass of carbon dioxide into the atmosphere. So we are far from reaching the goals that are stipulated in the Paris Agreement. The curve should not point upwards, but it should bend down, and it should do so very quickly. As you can see in the next slide, where the IPCC in its next special report that was published 2 years ago, the special report on the Paris goal 1.5 degrees Celsius, has estimated how much carbon dioxide the world is allowed to emit to still be able to reach the climate targets. The UNFCCC Paris Agreement looks at a climate target of 1.5 degrees Celsius, warming no more than before the pre-industrial. This means that there is a remaining budget of emissions of 493 billion tons of carbon. This sounds a large number, but it means that in today's emissions, if these emissions were kept constant, we only have 13 years left until that budget is gone. You can put it in a different way. You could ask the question, every year, what is the percentage of reduction if we want to reach the Paris target of 1.5 degrees Celsius? Well, you have to reduce emissions by 7.5% every year. There is the less ambitious target in the Paris Agreement of 2 degrees Celsius. The numbers look less ambitious, to 1,243 million tons of carbon dioxide, but that simply buys us only 34 years under current emissions. Or, put it the other way, minus 3% emissions every year. Year after year, further ambition to reduce the emissions. That is the voice of the science. These are the numbers. We know them. We have known them in 2015. We know them in 2020. And yet, education. What is education doing? How are we talking to the young people? How are we talking to those who enter school, who enter university? Education, the question is, was it early enough that we did address climate change and the question of resources and their limitations in the Earth system? Was it thorough enough? And finally, was it credible enough? I would argue that in these 3 points, we have simply failed in the last 40 years. And therefore, we need to widen our perspective. There is a real opportunity today to not only address climate change, but also to address the much wider topic of sustainable development. In the same year, the nations have agreed to the Paris Agreement. They also agreed a couple of months before to the 17 Sustainable Development Goals. Here they are. They are comprehensive. No poverty, zero hunger, good health, quality education, gender equality, clean water and sanitation, affordable energy, clean energy, decent work, industry, innovation and infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action, clean water, life on land, peace, justice and strong institutions, and finally, partnerships for the goals. These are the ambitious Sustainable Development Goals the nations have agreed 5 years ago. The target year is 2030. Well, let's look a little bit more differentiated at these 17 goals and ask the questions, are there interactions between climate protection and Sustainable Development Goals? You can ask the first question. Which of climate change has to be achieved to actually reach the Sustainable Development Goals? Of course, this is an exercise that has a certain degree of subjectivity in it, but I'll list here a subset of these 17 goals where climate change must be limited to achieve the goal. I just give you 2 examples. If you want to eradicate hunger, you have to deliver to the agricultural system a stable climate. If your climate system is not stable and warming is going to proceed and the water cycle is going to change, you will have big problems to achieve goal number 2, to eradicate hunger. Life below water, the food store of the planet of the future, is under big threat. Not only because of the warming of the surface ocean, but also due to acidification and its effect on the food chain in the ocean. Therefore, if we don't mitigate climate change, if we don't reduce carbon dioxide in the atmosphere, goal number 14, life below the water, is certainly not achievable. But you can also look at this issue the other way around. Which Sustainable Development Goals must be reached to limit climate change? What is a prerequisite? One certainly is quality education. If we have quality education, people understand what's at stake. People understand the processes that threaten our living and our livelihood in the future, in the 21st century. Gender equality, another goal, needs to be met if you want to reach and limit climate change. Why is that? Well, you can't exclude half of the population of this planet in your tough decisions to reach the Paris Agreement goals. And so if you now look at the two different subsets, 4 Sustainable Development Goals result: climate action, quality education, peace, justice, and strong institution, as well as responsible consumption and production. We can argue that these 4 Sustainable Development Goals yield us the best benefit when we address these problems, because they are also a prerequisite to limit climate change. Education is the key to success in Sustainable Development Goals. And I want to address here 3 points. In order for education to be the incubator for sustainable development, the education needs to be comprehensive, it needs to be credible, and it needs to be consistent. Let me go into detail in these 3 areas. Comprehensive education means that it is based on scientific knowledge. We need to know the facts of the environment. We need to know the level of pollution. We need to measure the extreme events. We need to be able to project the future based on scientific understanding of the Earth system today. Without scientific knowledge, education is meaningless. But in order to be comprehensive, education must also encompass human decision processes, because at the end of the day, it's human decision processes that determine what will be the next step in our fight for climate mitigation and sustainable development. In order to be comprehensive, higher education must also look at economy and law for the future. Not just analyze our present problems and try to stuff holes in our knowledge about economy and law, but forward-looking lawmaking, forward-looking economic models will contain also metrics about the cost of our actions today. In other words, if we squander resources, that must be a part of the economic models today. And finally, in order to be comprehensive, education must have as a topic the intergenerational equity. Intergenerational means that you are thinking all your processes from the viewpoint of the future generations, and not just your children, but you have to go further, even into the 22nd century. What does it mean? What are our decisions today for consequences of the future generations? The second point is about credibility of education. Universities must lead by example. If we are institutions of higher education, how can it be that we are using a lot of energy to heat our buildings? Our buildings should be warm, but in a sustainable manner. Universities must lead by example in their infrastructure, in their buildings, in their use of energy, but also in their catering of thousands and hundreds of thousands of students every day. They must lead the way in the way how water is used and how waste is managed. And finally, a sore point also for scientists and people in the higher education, it is about travel. Universities must lead in the way how people travel, how their staff travels and conducts meeting, how the resource management is actually organized in an institution of higher education. The final third point deals with consistency. Our education needs to be consistent, and that means the education in humanities is required for scientists. That is an old hat. Even when I was in university, at our university, we had to follow social science courses. I admit a minimum number, but nevertheless we did that. However, what is dearly and sorely required is that science is also entering humanities. Humanities need to have a basic scientific understanding, to be able to reflect their science in the light of the natural scientific facts. And that means, in consequence, that our economists that we are teaching today, they must be exposed to the essentials of sustainability. In their course, it has to be tested. They have to pass these courses in order to understand that this is an important element of a modern education. And the same goes for the lawyers. Sustainability essentials in law, I think, are crucial to confront the problems of tomorrow. With that, I'm at the end. Science and education, I'm fully convinced, are the key enablers of the fourth industrial revolution. The fourth industrial revolution is not digitalization. The fourth industrial revolution is sustainabilization. Thank you very much for your attention.